Now, in this question, we're asked to find out Marshallian demand functions for u equals to x1 plus x2. Now, u equals to x1 plus x2 is the form of perfect substitutes. Okay, so this is the form of perfect substitutes. Fine. So it's like Coke and Pepsi for some people, tea or coffee, okay, for some people, and so on and so forth. So these are like perfect substitutes. So if you go into the market and you ask for coffee and he says this that well, this is not available, okay, you will say, okay, give me tea. Or if you go into the market, both are available and you know them, you know this that both of these goods are giving you equal utility, then which one will you buy? You will buy a cheaper commodity. Okay, remember this, you will buy a cheaper commodity. Okay, so and let's define our budget constraint and etc. So if P1, P2 is the price vector and income of the consumer is M, our budget constraint is given by P1x1 plus P2x2 equals to M. Okay, so we are assuming this is our total expenditure and this is the income of the consumer. Entire income is spent in these two goods. Okay, nothing is saved. So consumer is consuming on the budget line, not within the budget line. Okay, so u equals to x1 plus x2. Now, there are several cases, okay, in this question. If P1 is less than P2, okay, and we are going to derive the demand functions for x1, okay. If P1 is less than P2, so which one is a cheaper commodity? X1 is a cheaper commodity. Fine. So, you'll buy all of x1 because it is giving you equal utility and it is a cheaper commodity. So what will you do is that you will not buy anything for x2. So your budget line will become p1 x1 plus p2 into 0 is equal to m. So this becomes x1 p1 x1 is equal to m, or your x1 would be equal to m upon p1. Clear? And this is a Marshallian demand function in this case. Fine, because it is in terms of income and prices. Remember this, that Marshallian demand functions are always in terms of income and prices. Okay. Now, second case is if P1 is greater than P2. P1 is greater than P2. So, which one is a cheaper commodity? X2. How much of X1 will you buy? Nothing. You will buy all of X2. So, your budget line becomes P1 into 0 plus P2 x2 is equal to m. Okay, so x2 is equal to m by p2, but since we are deriving the demand functions for x1, so x1 is equal to 0 out here. Okay, similarly p1 is equal to p2. Okay, then which one is a cheaper commodity? Both. You're indifferent. Okay, now you can buy only x1. Okay, you can buy only x2, or you can even buy some convex combination of x1 x2. Okay, so in case if you are buying only x1, okay, because it is giving you equal utility, you can buy only x2 because again it's giving you equal utility. You can buy some combination of x1 and x2, that is half cup of tea and half cup of coffee. Okay, like that you can even buy that because, and they're also giving you some utility. Okay, so supposedly if your let's fix a utility at equal to 5. Okay, what you can do is only x1 it will give you 5, only x2 it will give you 5, x1 plus x2 you can buy even 2.5 2.5. Okay, so like that, huh? All of them are giving you equal utility. Now in case of only x1, what is the demand function for x1? M upon p1. In case of only x2, what is the demand function for x1? equal to 0. x2 is m by p2, but x1 is equal to 0. In case of a convex combination of x1 and x2, I mean, it will be somewhere between these two. You're buying nothing of x1 or you're buying all of x1. So it will lie somewhere in between these two. So it will be 0 to m by p1. Okay. So these are the three cases, and these are your Marshallian demand functions for u equals to x1 plus x2. Okay. So what we have done is that in case of p1 less than p2, you're buying all of x1 in x1 is equal to m by p1. In case if p1 is greater than p2, p1 becomes a dearer commodity, and x1 becomes a dearer commodity and x2 becomes cheaper, so you're not buying anything of x1, so x1 is equal to 0 out here. In case of p1 is equal to p2, you are indifferent, so you can buy all of x1, you can buy nothing of x1, or you can buy some of x1. So it should lie within two extremes which we have already done. So it becomes 0 to m by p1, and these are your demand functions. Similarly, you can derive the demand functions for x2.